Okay, greetings. A lot of people have said that they've had trouble with these truth table worksheets, so I'm going to do a bunch of examples to help you out. All right, so here we go. These worksheets are different. Obviously, I'm not going to do the worksheet that I gave you because that's just silly. All right, the first thing that you should know is whenever you're doing a truth table, you always fill out these two columns the same. So you always start with true, true, false, false, and then you go true, false, true, false. Now, this is an example of logical thinking. Why should I do it that way? Well, the reason why is that it doesn't matter the specific pattern. I could have done false, false, true, 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 false, true, false. I could have done it a different way. Let me show this. Another one. Let me make it smaller so I have room. I could have done it true, false, true, false, true, true, false, false. Or I could have done it randomly. False, true, true, false, true, false, true, false. Sure, I could do it any way I want, but the point is that my end result has to end up with the four possible combinations of true and false for my two propositions. If I have more than two propositions, this is a different story. But all the ones I gave you are two propositions, so I'm not going to waste time, or rather, I'm not going to try go into more than that. Look, if I have two propositions like A and B or N and S or whatever the letters are, it doesn't matter. Okay, these letters don't matter. I could make them whatever I want, A and B, Q and R, P and Q, it doesn't matter. Okay, but there are four combinations of true and false when I have two propositions. The first is that they're both true. Okay, maybe the next obvious one is, oh, they're both false. Then you might say, okay, well, what's the other possible combination? Well, maybe the first one's true and the second one's false. And then the only other one that's left is the first one's false and the second one's true. You can think about this for as long as you want. There are no other combinations. Okay, you can also think about it like flipping a coin, right? If you flip a coin, replace F with H, and it's like, okay, if you flip a coin twice, you might get two tails or two heads, or maybe the first time you get a tails and the second time you get heads, or maybe the first time you get heads and the second time you get tails. The point is you have four different combinations, okay? And you have to cover all of those combinations because that's what we're interested in doing here with this truth table. We're interested in figuring out, okay, for all the possible combinations of these prepositions or propositions, what is the truth value of this logical expression? Now, if the word proposition and the word logical expression is confusing to you, then I suggest you go and look at the handout on my CCA. I went over it in class, so it's not news in the sense that it's not new, but maybe you forgot it or maybe you didn't take notes. That's okay. You can just go to my CCA and go to the topic for your class, and you will see that there's a whole list of handouts that will help you with these worksheets. In fact, um, these handouts really explain everything that I'm going to go over in the video. So I'm just doing this video because I love you guys and I want to help you, um, even though maybe I should let you struggle. All right, so check it out. Topics, boom. Introduction to logic. Logic definitions handout, logical truth tables handout. If you click on these will help you, okay? So logical definitions, proposition, logical operators, logical expressions, truth tables. It explains it. Logical truth tables handouts. It explains not, okay? The only thing that these handouts don't have is the and the or symbols. So that's the one thing that is not there, but I went over it in class, so I'll go over it again. And is like this. Sorry. And is like this. Or is like this. Okay? So and is like an up arrow, and or is a downward facing arrow. Okay? Everything else is in there. This is an arrow. That's if then. Okay? This on this worksheet, and these problems don't have the biconditional statement, which is the two-way facing arrow, but it does have negation. Okay? So all this stuff is in the handouts for you. The only thing that's literally the only thing that's not in the handouts is these explanations of these symbols. So and is this or is this. Cool. Now, not n. Now, the point is this. You fill out, I'm going to just go ahead and create a new one so I'm not confused here. You fill out the two columns, the first two columns, the same way every single time. And why do I say true, true, false, false, true, false, true, false? Because it's just easy to remember. True, true, false, false, true, false, true, false. True, true, false, false. And it's also a pattern. For instance, if I had another proposition here, I would do 4 trues and 4 falses. Then true, true, false, false, true, true, false, false. And then true, false, true, false, true, false, true, false. Okay? But I'm glad if you just caught what I just said really fast. But the point is this. This is how you do the first 2 columns. Simple as that. All right. Now, if you have something like not n, well, you have to fill out this column based on what you already have. Well, if n is true, then not n is false. Don't worry about making it into logical words in your head. The point here is just understanding the simple logic of these operators. But if you have to, then make up something like some proposition, something that's either true or false. For instance, today is Tuesday. Well, if it's true that today is Tuesday, then it's false that it's not Tuesday. And that's what negation is. It's just not whatever it is that the proposition is. So if n is today is Tuesday, then not n, the negation of n, is it's not Tuesday. So if n is today is Tuesday, then the negation of n is that it's not Tuesday. So this little tilde is negation. This one here, it's Tuesday. This one here, it's not Tuesday. Okay, if it's true that it's Tuesday, it's false that it's not Tuesday. And hey, still here, if it's true that it's Tuesday, it's false that it's not Tuesday. Okay, now let's look at this. If it's false that today is Tuesday, then it's true that today is not Tuesday. If it's false that today is Tuesday, then it's true that it's not Tuesday. Simple as that. That's how you figure out negation. And check this out. Boom. This negation is the same thing. Okay? It's a different proposition, but we can handle it the exact same way. Okay? So let's say M is today is Wednesday. Well, if it's true that today is Wednesday, then it's false that today is not Wednesday. If it's true that today is Wednesday, false. Look, the negation is just the opposite. If the proposition is true, the negation is false. And that is where I want you to get. You don't have to translate this into proposition because then you lose the value of turning the proposition into letters. If it's true, the proposition is true, then the negation is false. If the proposition is false, then the negation is true. Okay, now let's start with this one, the or, because it's a little bit easier. All right, so what does or mean? Well, what if I said to you, hey, today we're going to eat apples or bananas? And you're like, okay, that's cool. And then I give you some apples. You're like, oh, you didn't lie to me. That was true, right? Or I give you bananas, and you're like, oh, okay, cool. You told me you're gonna get apples or bananas today, and I gave you banana. You gave me bananas. Awesome. You're not a liar. You didn't lie to me. Okay, cool. But what if I give you oranges? You can look at me and be like, Mr. Manier, you just lied. You told me I'm gonna get apples or bananas, but you gave me oranges. Well, or means that, hey, if one of them is true, then the or expression is true. Also, I could have said, hey, I'm going to give you apples or bananas today. What if I give you both, apples and bananas? Well, I still didn't lie. I said, hey, I'm going to give you apples or bananas today. And in fact, I gave you both. Well, you might say, well, but you didn't, you said I'm going to give you apples or bananas. Well, it's still true. I still gave you apples and I still gave you bananas, right? So it's still true that I was going to give you apples or bananas. It just happens that I gave you both. Okay? So don't think that or means like only one of them can be true. It's it's not like you're choosing between one or the other. It's actually just saying, "Hey, as long as you're giving me one of these, either apples or bananas, I'm cool. You're not a liar. If you give me both, awesome. I don't have to eat both the apples and the bananas, but you still told me the truth. You're going to give me apples or bananas. Hey, you know what? You were nice and you gave me both." So the way that or works is as long as one of the propositions is true, then the or expression is true. So if not M, so now be careful. I don't care about M anymore. I just care about not M. I'm not evaluating the truth of M. I'm evaluating the truth of not M in this expression. I'm also evaluating the truth of R. So if either one of these is true, then this expression is true. Okay, so R is true, so bam. This expression is true. They're both false. This expression is false. They're both true. Yep, the expression is true. This one's false, that one's true. Hey, at least one of them is true. So the statement is true. And there you go. That's how you evaluate the or expression. Okay, so we handled negations, we've handled or. What about this one? If then, oh, that's tough. I don't know if I want to go into that one right now. Let's just jump into it. Might as well. Let's just go. Okay, if then. An if then statement is pretty clear. Okay? How it works is if the antecedent, that means the thing that comes before the arrow, antecedent, say it with me now, antecedent. If the antecedent is true, then the consequent must be true. The consequent is the thing that comes after the arrow. Everyone say it with me, consequent. If the antecedent is true, then the consequent must be true. Because I'm saying, if this is true, then this must be true. For instance, what if I said to you, hey, if it's block 2, then you have robotics. Now, excuse me, my block 4 class, this doesn't apply to you. Okay, or what? How about I say it as a teacher? If it's block 2 or block 4, then I have robotics class. Okay, cool. Well, if it's block 2 or block 4 and I don't have robotics class, then that's not a true statement. Because I said, if it's block 2 or block 4, then I have robotics class. And guess what? It's block 2 and I don't have robotics class. That's not a true statement. Okay, let me make it easier. I teach block 6 pre-algebra. If it's block 6, then I have pre-algebra. Okay, well guess what? If I show up and it's block 6 and I don't have pre-algebra, then that statement's not true because I just said if it's block 6, then I have pre-algebra. The antecedent is if I have block 6. The consequent is then it's pre-algebra. I have pre-algebra. If I say if it's block 6, then I have pre-algebra, that statement, that expression is if I have block 6, then it's pre-algebra. Then I have if it's block 6, then I have pre-algebra. That logical expression is only false if it's block 6 and I don't actually have pre-algebra. It makes logical sense, right? It's like, hey, you go up to someone in the hallways and say, hey, like if it's block 6, then I have pre-algebra. And then they're like, well, it's block 6. And then you turn around and be like, oh, I've got PE. They'll be like, you just lied to me. That you just told me a false statement. Okay? So that expression is only false if the consequent is true and the antecedent is false. What if you went up to that same friend and said, hey, if it's block 6, I have pre-algebra. And then you're like, oh, well, it's block 3. And you're like, oh, well, I have PE. Did that make this expression false? No, it sure didn't. It definitely didn't. Let me give another example. Let me say, um, what about this? If I say to you, hey, if you say to a friend, if it's block 4, then I have to go to my locker. And they say to you, okay, well, it's block 4. And you say, okay, well, I've got to go to my locker then. Okay, that statement is true. What about if you say, oh, it's block 5? And you say, oh, I don't have to go to my locker. Well, okay, that statement is still true because you said if it's block 4, then you have to go to your locker. You didn't say anything about block 5. But what if you say, hey, if it's block 4, then I have to go to my locker? And then your friend says, well, it's block 5. And you say, oh, I have to go to my locker. Did you say something false? No, your statement isn't false because guess what? Just because you have to go to your locker doesn't mean that it has to be block 4. It's just if it's block 4, then you have to go to your locker. But it also might be true that if it's block 5, you still have to go to your locker. So guess what? The antecedent could be true that you have to go to your locker, even if the consequent is false. Hey, it's not block 4, but I still have to go to my locker because it just so happens that I have to go to my locker on block 5 as well. Okay? So the only way that this is false is if you say, hey, if it's block 4, consequent, if it's or antecedent, if it's block 4, then I have to go to my locker, consequent. So if it's block 4, then I have to go to my locker. The only way that that expression is false is if you say that, hey, if it's block 4, then I have to go to my locker, and your friend says, oh, it's block 4, and you're like, I don't have to go to my locker. It's like, whoa, dude, you just lied. That expression was false. It's really that simple. Okay, so we know it, we understand it. This is just a formalized way of expressing these logical statements, okay? These logical expressions and evaluating these logical expressions, okay? We do it in our heads. We do it because we've been trained to understand logic since we understood language, basically, and even before then, really. You know, if you drop your pencil, right, it's gonna fall. You learn that like it makes sense based on inductive reasoning that if you drop your pencil again, it's gonna fall. So we understand logic even before we know language. So we know this stuff, but we formalize it, and by formalizing it, we gain mastery over it. Okay, so here we go. So if not n, then s. Again, we don't care about n anymore. We just care about not n. So the only way this is going to be false is if not n is true and s is false. If the antecedent is true and this consequent is false, then this statement ends up being false. Okay, so let's take a look. If not n is false, does it matter what s is? No, this statement is true. So here you go. If not n is false, this statement is true. And why? Because guess what? I have to say to myself, like, unless I can prove this thing is false, then I don't know it's false and it might as well be true, right? Your friend doesn't know whether or not you're lying to them if they say, hey, it's block 5, and you say, oh, I have to go to my locker, or I don't have to go to my locker. They only know that your statement is false if they say, hey, it's block 4, and then you say, I don't have to go to my locker. So therefore, if the antecedent is false, it's not block 4, then this statement is still true. Okay? This statement is still true until it's proven false. Okay, so here we go. The antecedent is true, it's block 4, and it's true that you have to go to your locker. Okay, this is true. Now look here. The antecedent, it's true, hey, it's block 4, but the consequent is false. It's block 4, but you're saying, hey, I don't have to go to my locker. Guess what? You just lied. This statement is false. Okay? And that's how a conditional statement works. Okay? If then is only false if the antecedent is true and the consequent is false. That's how it works. Okay. Boom. Let's move forward. Okay. Let's do an easier one just to give ourselves a mental break here. Okay. So, boom. RC, not C, R and not C. That's how you read that. All right, let's go ahead and fill in our first two columns. True, true, false, false. Look at this. I don't even have to think. Just do it. Awesome. Then not C, that's easy. If C is true, not C is false. C is false, not C is true. C is true, not C is false. C is false, not C is true. There you go. It's just opposites. Cool. Now, again, for my logical expression here, R and, remember this is and, that upward facing arrow, I'm interested in not C, no longer interested in C. I'm also interested in R. Okay, now, and works like this. What if I say to you, hey, today we're going to have both apples and bananas? And then I hand you apples, but no bananas. You're like, oh, dude, you totally just lied. that was a false statement because you said you're going to give me apples and bananas. You just gave me apples. Or what about if I give you bananas? Then you'll say, dude, you just lied. Like, you said you're going to give me apples and bananas, but you just gave me bananas. So that statement's false. What about if I give you oranges? So it's not true that I gave you apples or bananas. I didn't give you apples or bananas. Both those things were false. Boom. Of course, that was a lie. You said you're going to give me apples and bananas. You gave me neither. You gave me oranges. Not cool. That's false. What's the only way that this statement is true? Is if they're both true. If I say to you, hey, I'm going to give you apples and bananas, and then I hand you both apples and bananas. And so the way and works is they both have to be true. Okay? So notice how I simplified things by crossing out C and just saying, hey, I'm interested in not C. Then I'm not overthinking it. I'm not thinking, okay, C, not C. No, I'm just evaluating the truth values of these two propositions, R and not C. Okay, so the only way this is true, the and is true, is if both of the propositions are true. That's the only way that this is true. So this is true, that's false. This is false. That's both true, true. False and false, false. False and true, false. Okay, this is like, hey, I just gave you apples, but no bananas. Psh, liar. I give you apples and bananas? Oh, thanks for telling the truth. I didn't give you apples or bananas, I gave you oranges? False. I didn't give you apples, but I gave you bananas? Still false. You told me you were going to give me both. That's how this works, okay? That's and. Right, that's and. All right. That's it. Awesome. Okay. Now, finally, biconditional. This is arguably the most challenging one to understand, but as much as it's challenging to understand, it's doable. But before we go into that, let's just remember our first two columns we can fill out without even thinking. Yay. True, true, false, false, true, false, true, false. And then our third column, which is not F, is just the opposite of F. True, false, false, true, true, false, false, true. We're comparing not F, F, awesome. Then again here, we're interested in not F, okay? So I'm going to go ahead and cross out I. I'm just interested in I and not F. Now, biconditional. How does this work? Okay, it's like if and only if, but both ways. It's if then, but both ways. Biconditional, this two-way facing arrow, okay, two-way facing arrow means if and only if. So this is if and only if. Okay, so let's evaluate the language. Let's say, I'm going to give you apples if and only if it's Monday. Okay, well, now let's go deep. I give you apples and it's Monday. Well, hey, guess what? I said to you, I'm going to give you apples if and only if it's Monday. That means I'm going to give you apples if it's Monday and only if it's Monday. So not Tuesday, Wednesday, Thursday, Friday. No, no, no. The only day I'm giving you apples is Monday. But you better believe on Monday, I'm giving you apples. Okay? So I'm going to give you apples if and only if it's Monday. Monday rolls around, I give you apples. That's a true statement. Cool. But now, let's say Monday rolls around and I don't give you apples. Well, guess what? I told you I'm going to give you apples if and only if it's Monday, which means, hey, on Monday I'm going to give you apples. I'm going to give you apples if it's Monday, right? That's part of it. And Monday rolls around, I don't give you apples. Well, you lied to me, dude. Not cool. It's true that it's Monday, but it's false that you're going to give me apples. Well, that's not cool. It's still false, okay? So the first one, it's Monday, true, and the apples, true. They're both true, then the biconditional statement is true, okay? If it's Monday and that's true, and you don't give me apples, false. So one's true, the other's false. And well, guess what? That biconditional statement is false, okay? Because I said, I will give you apples if and only if it's Monday. Well, guess what? That means on Monday I'm supposed to get some apples. You're supposed to get some apples. Monday rolls around. So it's true that it's Monday, but it's false that I gave you apples. I don't give you apples. That expression is false. Okay? Does that make sense? If I say to you, I'm going to give you apples if and only if it's Monday, and then Monday rolls around and I don't give you apples, I lied to you. That statement was false. Okay? Now, what about another way? What about if I say, hey, I gave you apples, but it's like Thursday? Wait a second, dude. You told me you're going to give me apples if and only if it's Monday. But it's Thursday. You just gave me apples. Not cool. You said I'm only going to get apples on Monday. Well, you lied to me. You see? So it was true that I gave you apples, but it's false that it was Monday. Therefore, the biconditional statement is also false. So we see there, hey, if they're both true, then it works, right? It's Monday. You gave me apples. Nice. But if either one of them is false, then the statement is false, right? If one is true and the other is false, because guess what? If you gave me apples, but it's not Monday, you told me you're going to only give me apples on Monday. But it's Tuesday or Thursday. You're giving me apples. You lied. Or what about if Monday rolls around and you don't give me apples? Well, hey, you told me you're going to give me apples if it was Monday. You lied. Okay, so if one is true and the other is false, then the biconditional statement is false. The biconditional expression is false. But what about the last one? What if they're both false? What about if it's Tuesday and you don't give me apples? So it's false that it's Monday and it's false that you gave me apples, right? Well, guess what? That biconditional statement is still true because I said to you, hey, I'm going to give you apples if and only if it's Monday. Did I say anything about Tuesday? No. So if it's Tuesday and I don't give you apples, well, that's exactly what you expected because I told you I'm going to give you apples if and only if it's Monday. So those apples are only coming to you on Monday. If it's Tuesday and you don't get apples, well, of course you didn't get apples. I just told you I'm only giving you apples on Monday. So if they're both false, then guess what? That biconditional expression is true. Simple as that. Okay, so let's take a look. One is true, the other's false. This is false. Both are true. This is true. Both are false. This is true. One is false and the other one's true. This is false. Let me break it down, right? Hey, it's Monday, but you didn't give me apples. Liar. It's Monday, you gave me apples. Sweet, you told the truth. It's not Monday, you didn't give me apples. Still not a liar. You still told the truth because that's exactly what I expected. Or, hey, it's not Monday and you gave me apples. You lied because you told me you were going to only give me apples on Monday. So that's what if and only if means. This is a biconditional expression. Biconditional if and only if. That's how you evaluate it in a truth table. Okay? So now we've gone through or, conditional slash if then, and now biconditional if and only if. Sweet. All right, we've gone through everything, negations. What I'm going to do now is I'm going to blast through another entirely different worksheet. So you guys are going to see my secret here, mathaids.com. Oh man, create it. These are epic worksheets here. Feel free to create your own worksheets and just do worksheets for fun at home. I'm just really proud of you if you choose to do that. Cool, so here we go, Bajoom, Bajoom, Bajoom. All right, let's just break this down. Let's make it real fast. Forget all the colors. I'm just black and white in it. True, true, false, false, true, false, true, false. Okay, not J. That's the opposite of J. So it's false, true, false, true. Okay? And then here, now we're evaluating not J, so I can forget about J. I'm evaluating not J and F. This is the if then. So this is only false if this is true and this one is false. Remember, this is only true. This is only false if the antecedent is true and the consequent is false. So, hey, look at here. F is true, the consequent is false. This is false. They're both true. This is true. They're both false. Doesn't matter to me. It's still true. The antecedent is false, but the consequent is true. The statement's still true. That was the one about the locker. Remember, hey, it's not block 4, but you still went to locker. Still true. It's not block 4, you didn't go to your locker. Still true. It's block 4 and you went to your locker. True. It's block 4, but you don't have to go to your locker. False. Liar. All right, boom. True, true. False, false. True, false. True, false. Not O is the opposite of O, so that's going to be false, false, true, true. I was comparing it to O here. Again, I only care about not O and T, so I'll get rid of that. And comparing not O and T, those truth values. All right, now the biconditional is true when they're both the same. So if they're both false, true. If they're both true, true. If they're opposites, so true and false, then it's false, or false and true, then it's false. Simple as that. So I explained to you all this stuff, and now it's just like, oh, like conditional statement, only false if the antecedent's true and the consequence false. Cool, that's a rule. Biconditional statement, well, that's true as long as they're both the same. So if they're both false, it's true. If they're both true, it's true. But if they're opposites, then it's false. Dude, love it. Okay, now moving on. Next one. Those were the hard ones. Let's go to the easy ones, right? Shall we? I think so. Okay. All right, guess what? I do my first two columns the exact same. True, true, false, false. True, false, true, false. Awesome. Not S is the opposite of S, so I'm comparing it with this column. That's false, that's true. Not Q is the opposite of Q. I'm comparing with this column, so it's false, true, false, true. I'm interested in not S and not Q. So get rid of Q, get rid of S. You don't have to cross them out, but it just makes it easier in your brain. Remember, and is only true. This is and, right? It's only true if they're both true. So this is false, this is false, this is false, this is true. Remember, if I'm giving you apples and bananas, well, I have to give you both. Otherwise, you lied. Only gave you apples? False. Only gave you bananas? False. Didn't give you either? False. Awesome. Okay, B or G? Well, they made it easy on us this time. No negations. So true, true, false, false. True, false, true, false. Sweet. Okay? Or, remember, or is true as long as one of them is true. Okay, so the only way that or is false is if they're both false. So boom, they're both false. Like I say, I'm going to give you apples or bananas. It's cool if you give me both, right? It's cool if you just give me apples. It's cool if you just give me bananas. Okay, the only way you become a liar is if you give me neither. All right, and that's it. Okay, this is how you do truth tables. I know this has been challenging for you, but I hope this video helps. I think you guys can do it, and I think that you will be blessed by learning this. Okay, so until next time, that's it for me for now. Love you guys.